Hey everyone, Victor is here, and in this video I want to talk about a rather interesting reaction called Darzens reaction, which going to convert an aldehyde or a ketone into the corresponding epoxide by reacting with the alpha halogenated ester, or potentially other carbonyls as well, but this reaction works the best for esters. So to show the mechanism, I'm going to start by redrawing my starting materials, and the very first thing that we are going to see happening here is the enolization of our carbonyl. This alpha position that we have right next to our carbonyl and the corresponding proton on that is fairly acidic due to the presence of the chlorine on that position, so the base that we are using here, ethoxide, can easily come in and deprotonate that position like so, giving us the corresponding enolate intermediate. And as we know, enolates are fairly nucleophilic species. And at the same time, in our solution, we have an aldehyde, which is of course is a very good and a very strong electrophile. So naturally, those two species are going to interact with each other, and we are going to have a nucleophilic attack from our enolate on our aldehyde like so, giving us the corresponding halohydrine intermediate. The new bond that I have created is right over here, so I'm going to show it as a new bond, and we have created that new bond between our alpha carbon, which was this carbon over here in our enolate, and the carbon of our aldehyde. Let me mark that, I don't know, in purple, so that carbon is right there. Now, the next step in this reaction is going to be an intramolecular SN2 reaction, where the oxygen that we have right over here, that oxygen is going to be playing a role of a nucleophile and intramolecularly attacking the alpha carbon again, displacing our chlorine like so, giving us our final product, the epoxide, which is going to look like this. And right about now, I can already hear, I can sense that some of you are going to question me saying that, well, this carbon over here, that is a tertiary carbon, which is a pretty crowded carbon. How is that possible to even have an SN2 reaction on that carbon? Wouldn't that be way too crowded? Wonderful question. Let's look at that from the perspective of the Newman projection here. So what I'm going to do, I'm going to draw a Newman projection where my carbon where the oxygen is going to be my front carbon, and the carbon where the chlorine is, that one is going to be my back carbon. So for my front carbon, I'm going to have the following picture, and the exact stereochemistry here is not super relevant. It can be either or stereochemistry, that's not the point here right now. What is important though is that when I draw my back atom, we can now clearly see that the oxygen and the chlorine can be antiperiplanar to each other, and the carbon-chlorine sigma star, the anti-bonding orbital that needs to be populated for this intramolecular reaction to happen, is literally overlapping with the orbitals of our negatively charged oxygen. So there is actually no steric hindrances there whatsoever. The reaction is incredibly favorable, and it happens very easily. So while SN2 reactions are normally extremely sensitive towards the steric hindrances, it doesn't really apply for the three-membered ring formation like what we have in this case. Now, here is another example. Here we are going to start in exactly the same way how we did in the previous case. We're going to take this hydrogen in the alpha position, I'm going to bring my base and pull that proton off, like so, to make the corresponding enolate. Now, I'm going to bring my aldehyde so we can have our nucleophilic attack from our enolate on the carbonyl of our aldehyde, making our halohydrine intermediate, and of course, like in the previous case, our new bond is right over here, our new carbon-carbon bond, and the very last thing that is left for us here to do is to close our epoxide, kicking the chlorine out, giving us our final product that looks like this. How cool is that? I think this is an incredibly awesome reaction. Have you ever seen anything like that? Let me know in the comments below. And as always, thank you for watching. If you learned something new today, boop the like button and subscribe for more. Check out this video next, and I will see you next time.